Hello everyone. Today we will solve together a sample question from the chemistry test for students taking life science in the Lebanese syllabus. This is the exercise 1 in the first session 2024, and it's about titration of a strong base. In this question, we have a household solution of sodium hydroxide called S0. We don't have the percentage by mass of NaOH. We have the density and the NaOH given. The aim of this exercise is to determine the percentage by mass of NaOH in this household product S0. In the first part of this exercise, we need to prepare a solution S1. So this solution is prepared by diluting 100 times the commercial solution S0. And we need to choose from this document the most appropriate set that will help us to prepare the solution S1. Okay, so to start, let's talk a little bit about the dilution process. We have a solution that is called S0. Let's call the concentration of this S0 C0. And from this solution S0, we need to prepare another solution called S1. Let's name the concentration of S1 C1. To do this, we need to take out a volume called V0 from S0, and we need to put this volume V0 inside another container. This container should basically be a volumetric flask because the volumetric flask is more precise than the Erlenmeyer flask. So directly from this first option, we can remove set 1 because in set 1 we have an Erlenmeyer flask, and Erlenmeyer flask will not work to get a precise volume of S1. So it should be a volumetric flask. Now, let's write if you want, the formula of dilution. So we have C0 divided by C1 equals to V1 divided by V0 equals to the factor of distillation, which is in this case equal to 100. So we're diluting 100 times. 100 times. Okay? So we can conclude from this formula that V1 should be equal to 100 times V0. Let's talk about the two remaining options that we have. V0 should be taken by graduated pipette or volumetric pipette. Both of them can work. The difference between a graduated pipette is that there is a graduation of 5 milliliters, so this is the graduated pipette. There is a graduation, so we can take, it's a maximum of 5 milliliters, but we can use it to take 3 milliliters, 2 milliliters, and so on. The volumetric pipette is only 10 milliliters, so there is only one volume that we can take using this pipette, which is equal to 10 milliliters. Okay, let's go back to the formula that we have. If the last volume is 250 milliliter, if V1 is equal to 250 milliliter, this means that when we're using the set 2, V0 should be equal to 250 milliliters divided by 100. So it should be equal to 2.5 milliliter. Now, if we're using set 3, I'll change the color. If we're using set 3, this means that V0 in case of set 3 should be equal to 500 divided by 100, which is equal to 5 milliliters. So, in case of set 3, V0 should be equal to 5 milliliter, but the problem is that we don't have a pipette of 5 milliliters. We have a pipette of 10 milliliters, and it's a volumetric pipette, so we can't use it to take out 5 milliliters. So set 3 is for sure cannot be used. The one that can be used is set 2 because we have a graduated pipette of 5 milliliters, and we can easily use this pipette to get a V0 of 2.5 milliliters. So actually we're taking out 2.5 milliliter. This is V0 using the graduated pipette. We're taking it out from the S0. We're putting the 2.5 milliliter here inside the volumetric flask, and we're adding water until we get the 250 milliliter inside the volumetric flask, and this is how we can form S1 using set 2. So that set 2 is the correct answer here. Now let's go to the second part, pH metric titration. Here in this question, we are using the titration process of S1. taking out a volume of 20 milliliter of VB, of the base of NaOH, and of the molar concentration CB is introduced into a beaker. Then we add some distilled water in order to immerse the pH meter, and then we are doing a pH metric titration using a solution of hydrochloric acid. So basically, this is an acid-base titration. We have the concentration of the acid, and we have the volume um, that we are adding, the volume of equivalence. In these three parts of the question, this is a general knowledge about the acid-base titration. And in this question, the first they are asking us to name the glassware used to withdraw the volume VB of sodium hydroxide solution. This volume is equal to 20 milliliter. And this volume has to be precise. So to take out a precise volume, we can use a 20 milliliter a graduated or a volumetric pipette. I prefer to use the volumetric pipette. Volumetric pipette. Now, how to add the solution, how to add the acid, the hydrochloric acid solution in a titration process? The acid solution is always added using something called a burette, and it has to be a graduated. You need to write graduated burette, and this burette should be maximum 25 milliliters. Why? Because from these 25 milliliters we need to get 21.2. So it's logic to put 25 milliliters, so we can add 21 milliliters from these 25. Now write the equation of the titration reaction. This is a acid-base and acid-base titration, and the titration equation is always the same. It's a reaction between H3O plus HO negative, which is the base. This is the acid, this is the base. It's giving me H2O. And to balance this reaction, we need just to add the coefficient 2 here. You need to memorize this equation. Once they are asking you to write the equation of the titration, you can directly write it. This is the titration equation of a strong acid and a strong base. Now justify based on the chemical species present that the solution at equivalence is neutral. So this is basically an acid-base titration, and this is also a fixed answer that you can memorize and answer and write it all the time for these kind of questions. So you should say that at equivalence, the chemical species present in a solution other than H2O are Na plus and Cl negative. From where Na plus is coming? So we have an NaOH plus HCl. So OH and H will form the H2O, and what is remaining are only the ions Na plus and Cl negative. So Na plus and Cl negative are called spectator ions, and they have nothing to do with the pH. But the pH is neutral, equal to 7, which is the pH of water, H2O. Okay, so my advice for you is to memorize this sentence and this reaction, and always write it in these kind of questions to get higher marks. Now let's go back to the calculation part. I put it again. This question is because now we are using the numbers that are given to first determine the molar concentration of sodium hydroxide in the solution S1. So again, we have I draw a photo here. By the way, drawing photos is always helping in chemistry to understand the question and to understand what do they want from us. So here we have the base. The base has a concentration of Cb, and we don't know this concentration. This is the one that we need to calculate. And we have Bb equal to 20 milliliters, because they told us here that a volume Vb of 20 milliliter of sodium hydroxide is added to this beaker. Then we are doing the titration process using, as we said, the graduated burette. And in this burette, we're putting the acid, Ca, and we have the concentration of acid. It's equal to 7.5 times 10 power negative 2 mole per liter. Also, the volume that we are adding is the volume at equivalence is equal to 1.2 milliliter. Great. So now let's talk about the formula of, let's talk about the titration process. We can write that the Ca, let's call them Ca, the concentration of acid multiplied by the volume of acid added at equivalence equal to the concentration of base down in the cylinder multiplied by the volume of base. Okay, we have a problem in changing the milliliter to liter. You can do that. You can use the volume in liter, but during the calculation, we will be dividing these two volumes, the volume VA and VB together. So once we divide them, there's no need to change it to liter. But you can do that. You will obtain the same answer. So how to calculate CB? CB is equal to CA VA E divided by VB. This is what I meant by we're dividing the two volumes together, so there is no need to change it to liter. And again, if you're changing it to liter, means that you're multiplying here by 10 power negative 3 and here by 10 power negative 3, which will cancel each other. So there is no need to change it to liter. Now, Ca is equal to 7.5 times 10 power negative 2 multiplied by 21.2 and divided by 20. If you do this calculation, answer here is equal to 0.0795 mole per liter. This is, guys, the concentration CB, 0.0795 mole per liter. Okay, great. So this is 2.4. Now, how to solve 2.5? We need to show that the molar concentration of the commercial solution as 0 is C0 equals 7.95 mole per liter. Remember in the previous slide, I told you to always remember that the concentration of the base that we're getting here is a diluted one from C0. So C0 is equal to 100 times C1. Now we need to go back to the formula of the dilution. So the formula of dilution is telling me that C0 divided by C1 is equal to 100. So C0 is equal to 100 times C1. C1 is CB. C1, this is the base that is used here. So C0 is equal to 100 multiplied by 0.0795, which is equal to 7.95 mole per liter. And this is how we get this number. Now, this part of the question is about the percentage by mass of NaOH in the commercial solution. That's why I cropped here, I copied and pasted the first part of the question where they gave us the density and the molar mass of NaOH, because here we will use this information. And let me also write what did we get from the previous question, the 2.5. We got that the concentration of C0 is equal exactly to 7.95 mole per liter. Here, to calculate the percentage by mass, there is two methods. The first method is basically based on our understanding of the word percentage by mass. So percentage by mass is equal to the mass of NaOH divided by the mass of the solution, of the old solution, for sure, multiplied by 100. Now, how to get the mass of NaOH? Again, we have a concentration of 7.95 mole per liter of NaOH. So this is the concentration of NaOH. From this concentration, we can get the mass of NaOH easily. The formula relating the concentration to the number of mole and volume. So concentration is equal to the number of mole divided by volume. Let's consider that we are working in a 1 liter volume. So in 1 liter, we have N equal 7.95 mole of NaOH. Okay? How to get the mass from the mole? This is using the molar mass that we have here. So mass of NaOH is equal to the number of moles, 7.95, multiplied by the molar mass, which is 40. In this case, the answer will be 318 grams. So there is a 318 grams of NaOH inside a 1 liter solution. It's very important to know in which volume we are working, in 1 liter. Now let's talk about the solution. We have the density of the solution. The density is telling us that in 1.25, there is 1.27 grams in 1 milliliter. So if we need to change this 1 milliliter to liter, we need to multiply by 10 power negative 3 now to get it in liter, to change it to liter. So 1 times 1 power negative 3 liter. Okay, so this density will be equal to 1270. If we divide them, we'll get this answer, grams per liter. This is the mass of solution in 1 liter. Now, to calculate the percentage of mass, as I already said, we need to divide the mass of NaOH, which is 318, divided by 1270 and multiply it by 100, which is basically equal to 25%. This is the percentage by mass of NaOH in 1 liter of solution. So this is the first method. Now, the second method is using the formulas. I know some students understand more or can work better with formulas. So I presented also for you and we'll obtain the same answer. So the mass of NaOH divided by the mass of the solution. The mass of NaOH is equal to the number of mole of NaOH multiplied by the molar mass of NaOH. And the mass of solution is basically equal to the density of the solution multiplied by the volume of the solution. V, the volume of the solution. Okay, we know that the formula of density is equal mass divided by volume. So the mass is equal to the density multiplied by the volume. Okay, now the concentration is equal to the number of mole divided by volume. So this N divided by V, we can replace it by the concentration C0 because this is the number of mole divided by the volume. So C0 multiplied by the molar mass divided by the density is basically equal to the percentage by mass. For sure, don't forget, guys, don't forget the multiplied by 100. We need always to multiply by 100. Okay, let's calculate it. C0 is equal to 7.95 multiplied by the molar mass, which is 40, divided by the density. Again, the density, we should change it to grams per liter because we can't use milliliter. Because we're working in a volume in liter. The volume should be in liter because the concentration is 7.95 moles per liter. So this has to be changed, 1270 grams per liters multiplied by 100, which will give us the same answer, 25%. Guys, you have the right to use the method that is more convenient to you using our understanding of the percentage, and we will get the mass of NaOH separately from the mass of the solution, divide and multiply, or you can use directly this formula if you find it easier. Now, in the last part of this exercise, they are asking us to specify if the following statements are correct or false. The first statement is saying that the initial pH value of the solution in the beaker decreases when we add distilled water. So let's remember that in the beaker, we have the base, which is containing OH negative ions. When we are adding water, the concentration of OH negative will decrease, but the number of mole of OH will not be affected. So the number of mole of OH negative will be conserved, but the concentration of HO negative will decrease because we're adding water. We know that the POH is equal to negative log concentration of OH negative. When this concentration of OH negative is decreasing, when OH negative is decreasing, this will cause the POH to increase. And we know that pH plus POH should be always equal to 14. So in case of the increasing in POH, the pH should decrease. So this statement here is correct because the pH, they are telling us that the pH of the solution in the beaker will decrease, which is correct. Now, for statement 2, the pH of the solution tends to 0 upon the addition of a large volume of hydrochloric acid to the solution. We know that when we are adding acid to a base, so while we're adding the acid, the base will be, the reaction will happen between the acid and base, and a neutral solution will be formed. After the neutral solution, when the concentration of OH negative will be over and we're adding more acid, this will cause this solution here to be an acidic solution, and the pH of this solution will for sure decrease. So the pH of the solution will decrease, but here they are telling us that the pH tends to 0, which is, there is a question mark here regarding to the 0. So the pH will decrease, but it will decrease until which value? Is it actually 0? We should ask ourselves this question. We're adding this acid HCl, and we know that from the previous questions that the concentration of HCl is equal to 7.5 times 10 power negative 2. So the pH should decrease until it will arrive to a value which is equal to negative log, where we have only the acid, negative log concentration of the acid, which is negative log Ca. So this is equal to negative log 7.5 times 10 power negative 2, which will give us 2.12. So the pH will decrease until it will tends to not 0. This is wrong. Thank you so much. We're basically done from this exercise about the titration of a strong acid. I hope you understood all my explanation. And please subscribe for more videos from chemistry questions from the Lebanese curriculum.